AGI has not been cracked. This isn't really step-by-step reasoning. This isn't planning. Ultimately, you're still relying on a context window of characters. To the model, there is no step. They use special characters to create a notion that there is a break, and it learns that that special break character means that there is a next step in the same way that a space or a period indicates that there is a break semantically. But it is not that there is any real sense of time. It's still doing the same thing that LLMs are already doing, which is token by token by token by token, outputting things, and it produces symbolic representations that are meaningful to us. I promise you that Q star it's a variation of reinforcement learning with human feedback. And that process doesn't even play out in the end product. It is only in the process of training it that this even occurs. So when you deploy the model in its final state, Q star isn't even running. That's just the process by which you update the parameters to get to the model that you want, that does the things that you want. But it's just sampling from the collection of human knowledge. And math is a very structured thing. And all that it needs is already in the model. It's just sorting through the noise. There is a number of leaks regarding something called Q star. And these leaks have taken root because there was a lot of drama at OpenAI, and a lot of people are very uncertain as to why that happened, and they really want to know why. And so they have been zooming in on the company, trying to understand what's been going on. There have been two leaks, one which is reasonable and one which does not deserve amplification. The first is the basic claim that they were training on some algorithm called Q star, and that was working on solving math problems, and they claim they got to 100% on the math test. This is exciting. It is exciting because they were struggling a lot on math benchmarks. The GPT 3.5 supposedly only got about like 40%. In May, they released a paper that got to about 78%. And with this approach, they got to about 100%. But that does not mean that the process of training it on this task has enabled it to do things outside the domain of what humans have directed it to do. It does not mean that it isn't creating new math. It does not mean that it has access to infinite amount of compute to be able to continue processing when there is uncertainty about a problem. It does not mean it has the capacities to self-direct. It is still the foundational same paradigm of how large language models work, which is that you take a lot of data, you do a initial pre-training process where you just predict the next token, and that takes a very, very long time. And then you do a second round of fine-tuning of that model where you refine the parameters based off of some type of human feedback to get it to align more with our expectations of how it should behave and how it should function to make it play nice, okay? So, as I was saying, the thing that is very likely true is what is in alignment with what they have already published publicly about. They have, in May of this year, they published a paper called Let's Verify Step by Step about something called process reward models, which are essentially, instead of going from math problem to the answer right away, we show our work, right? We go step by step by step. This helps for humans. It's basically the machine learning equivalent of saying sound it out. You know, when you have a word that you can't pronounce as a child, you say sound it out, break it up into parts, right? And this shouldn't be surprising. If you are working with ChatGPT, if you have wrong answers in the context window, it starts to do worse. A lot of people ask me how I get such quality answers out of GPT-4 when it's not working for them. And I just say, I just delete the wrong answers. Because if you have a long stream of it getting it wrong, what it starts to do is model a conversation with somebody who doesn't have the right answers, right? So if you have a long stream of it getting it right, it getting it right, it getting it right, and it's only generating a small amount, the next part, it's going to do a lot better. And they have been working on this for a while to improve the capacity of GPT to do math. So let's sort of scroll back and talk about how they have been training the GPT-4 to do all the things that you're familiar with, and how they have been reapproaching this problem to train for math, and how those problems kind of differ. Okay. So the primary difference between language and math is usually there's just one very specific answer, right? There is not a lot of room for semantic vagueness. When we're talking about alignment or talking about textual outputs, there are a lot of things that can satisfy the people using the code that are the output. But with math, there is one right answer. There's very little room for error, okay? So when we are talking about how we refine these models, we start with this big pre-training. We're just predicting the next token. And by predicting the next token, we're taking all of human knowledge, all of the noise and all of the signal, all of the contradictions and conflict within, collective human knowledge, all of the human shadow and all of the human light, and it's all in one place. And it is trying to simply just predict the next token. That does not get us close enough to be a functional tool that we can use. So what they have done is this second round of fine-tuning. Part of it involves just human curated data sets where they are doing continued predicting the next token with a focus on we expect it to behave this way. But the big thing that has been the breakthrough is something called reinforcement learning with human feedback. The way that reinforcement learning with human feedback works is that you have humans basically rate in order of quality a number of outputs from the model. You have a singular prompt and it'll give multiple responses, and people will say which is the best, right? And then in order to train on that rapidly, what they do is they train something called a reward model. The reward model is being trained to predict how people will respond to the reward. And then what they do is they can very rapidly use that as a proxy for human response. So they can have it produce many different answers. The reward model will predict what humans would say, whether it's a good or bad response, and then it will update its parameters in relationship to that reward signal. That works very well on these semantic things. It does not seem to work so well on math, and it also doesn't seem to work very well on programming because GPT-4 is a dog shit programmer, and it drives me crazy. It doesn't work very well. So what they have done is in May, they released a paper called Let's Verify Step by Step. This process involves multiple steps of reasoning. That process involved scoring each step in the process by the quality of it. And that is done in a similar way. They train a reward model on human answers where they are ranking the quality of each step, and then that serves as a proxy for the quality of each step. So when it's trying to get from point A, which is the math problem, to point B, which is the math answer, and you have these multiple steps, if it ever produces, if the reward model ever says, oh, this is a very bad step, it can stop, right? So you can basically traverse step by step until you get to what you think is a bad answer. And this got them from 40% in with GPT-3 to about 78% on these math benchmarks. And the claim now is that Q star is getting them to 100%. I think this is probably true. But I do not think that because it is now able to do math better, that it suddenly is solving anything out of domain, or that this can generalize to doing tasks that has never been done before. In particular, what we have within the math domain is that you have a very clear success signal. That's very important when you are trying to train a model. If you look at something like AlphaGo, it's a game. There's a win state. So you can take the humans out of the situation and you can have self-play. You can have the model play against itself many games. And because there's an ultimate signal that says you have succeeded, it can just keep going. But language is not really like that. Language is a reflection of the real world, which the model does not have access to. It is trying to create a representation of the underlying belief space, a sort of world model of belief that helps it efficiently predict the next token. And by all means, there is more than enough knowledge within the training set for it to be able to do math up to 100%. It's just that, math is hard. There's a lot of wrong answers out there. And so if you just try to predict the next token, you're also modeling everybody who does bad math. You're also modeling everybody who got it wrong. But there's more than enough information to be able to traverse through that semantic space from the point where you have the problem to the point that you have the correct answer, if you can verify step by step by step by step, and you can improve the process of getting from point A within this large semantic space, which is the original model, to the endpoint, which is the correct answer. In order to do that, you have to have a fine-tuning, usually a reinforcement learning model. Now, what I'll say is that there is something that is called, let's see if I can bring this up. There is something, a paper that was released in March of 2023 called Q star, which is a combination of Q learning, deep Q networks, and A star, which involves a similar process. But one of the things that I really want to point out is that this isn't really step-by-step reasoning. This isn't planning, right? Because ultimately you're still relying on a context window of characters. To the model, there is no step in reality. There is no breakage point that says this is one message, this is the next, this is one step, this is the next. They use special characters to create a notion that there is a break, and it learns that that special break character means that there is a next step, in the same way that a space or a period indicates that there is a break semantically. But it is not that there is any real sense of time. It's still, in the end, when you train this large language model on Q star, if it exists, which I think it probably does, it's still doing the same thing that LLMs are already doing, which is token by token by token by token, outputting things, and it produces symbolic representations that are meaningful to us, right? That are reflections of our own understanding of the world. And because we make a lot of judgments about intelligence by this symbolic knowledge, we see something in that that represents some true understanding. But that's not artificial general intelligence at all. That's just tracing a pathway between a starting point and an ending point based off of the collection of human knowledge that has already been established, right? It's not doing something like stepping far outside of the space of reasoning to find a brand new type of math. It is not doing something where there is not a clear target, right? When we think about you or I, when we address the world, there is no inherent signal that says, okay, you are succeeding or you are failing. You basically feel it out. You vibe it out. Your attention flows different ways, and you have to decide whether you are successful or not based off of that. Like, in my process of reviewing this, there is some general intelligence that I'm using. I am having to keep going. There's no particular endpoint of my processing until I feel a sense that I have plugged all the pieces together, that when I flow through it every single time, there is no error, right? There's no particular point at which I could say, oh, this is the termination point. No, I just kept going day by day by day. I kept thinking about it, feeling like maybe I've got it, maybe I don't got it. People kept posting new things that I would watch or I would read, and I would be like, oh my God, they just do not care in the same way that I do about this being true. They just want to get it out as soon as possible. They want to say whatever people are speculating, and as long as they add a little asterisk that says, oh, well, take this all with a grain of salt, then it's fine to talk about it. It's fine to put out misinformation into the world, right? So again, does solving math problems mean that we have AGI? Well, think about it this way. What they've basically done is reinvent a calculator in symbolic language. A lot of these math problems that they are solving could already be done with far less energy in calculation. We just have this expectation that computers do math well, so that when large language models couldn't do math well, we're like, okay, that's weird. And so now they seem to be able to do math well because they have this different process of training. It does seem to be a multi-step reasoning where there is like a search graph in a similar way, where there is an evaluation of the value of each particular step down that path. It does seem like we're trying to reach a shorter pathway between those steps, but ultimately we're able to do that because we can explicitly say the correct answer, and because there is a very structured nature to math that if you have the rules, that you can always trace through to the answer. When we're talking about inventing brand new things or looking at a situation in a very generic sense and thinking about time and our relationship to time and our relationship to uncertainty, it is not as clear. Large language models still do not have any realistic relationship with time. They are not embedded in a timeline. They are not enabled to have continuous access to keep computing, and they are still at their final step just acting in response to a human prompt. It's always initialized by something that a human has said. It is never just going off on its own and then just continuing to go forever. And even if you set up some sort of loop that's doing that, it's because you have set a target in natural text that you're saying this is where you should be going, this is where you should continue to be operating on. It's not operating in relationship to the world. It's not doing real planning, right? This isn't actual planning. It's about as much of planning as you just writing out steps to plan in GPT saying, can you make a plan for me? That's about as much as it is. So to conclude, we've not gotten to a point of AGI. We have not cracked encryption. We have not seen a model take initiative to do all sorts of things that we did not request it to do. The model is not self-directing in any way. The foundational architecture of large language models remains the same. It remains that the ultimate product that you're using is you provide it with a prompt and it responds to you. And to achieve that, they have a first set of training, which involves predicting the next token. And then they have a second set of training that involves human feedback in some way. And they realized that the reinforcement learning with human feedback, where you are rating in order the quality of the answers, does not make as much sense for math problems because there's really only one answer. So they take the value of that and apply it to the steps between, where they have human labelers label the quality of each step that it's taking to get to the end point, right? And so it's able to generate all of these potential pathways through semantic space, through the model, to get to the end state. This is the outcome supervised reward model, which versus the process supervised reward model. The outcome is you're only giving feedback for whether it got the right answer. The process supervised model is you are giving it feedback on each and every step. This reads very, 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 very closely to the notion of Q star. And there's another paper called DAR. It's like a multi-step reasoning thing. It seems to be in the same vein of the problem, which is that we're going step by step. But again, it's really just the notion that if you have a large context of what the answers already are right, then the next step is not that hard. And it takes many reasoned steps to get from the problem to the answer. But in the end, ultimately what we're doing is we're showing the work. And because we're showing the work, people can evaluate and know how it's going through that process. It's providing interpretability to the process by which it is achieving that goal. But it doesn't mean that there's some sort of understanding. It doesn't mean that there's some self-directed capacity. And it doesn't mean that you need to be afraid. And it doesn't mean that humanity is in danger for the reason that people say. I still maintain that humanity is in danger, and it's for none of the reasons that people are saying. You are not in danger because it's going to suddenly become self-aware and kill us all. You're in danger because we are evolved to perceive a sense of the other through very simple mechanisms, and we are hacking those mechanisms. We are hacking our sense of reality itself. We are creating generative representations that are confusing to us, right? Where we can't really tell or understand without a lot of knowledge why it's doing this. I'll add a little bit of a philosophical star on this, which is that I think the reason people have a problem with this is because they identify so closely with their thoughts. They view themselves in the product of their own intelligence as their thoughts. They don't view their thoughts as being something arise from their subconscious through some neural mechanism, and then they, as a higher integrated intelligence, which we don't fully understand how that happens yet, is responding to that interface, the interface of thought. Right? What we seem to have invented with all these generative models is subconscious thought, the part that we don't identify with, the part that we call our brain. And there is a way to detach yourself from your own thoughts in a way that you no longer identify them with them as much. Mindfulness meditation is very valuable, for example, if your mind is very self-critical of itself, if your thoughts tell you you're stupid or dumb or something like that, or if you have OCD, then you can change your own relationship to the intelligence that is fed forward to you by the underlying apparatus, right? But that does not mean that the fact that we have recreated the sense of subconscious thought through the artifacts of our thoughts over time does not mean that we've recreated consciousness, does not mean that there is an identity within the model that is placing itself in existence in relationship to time. It doesn't mean that it wants to protect itself. It doesn't mean that it's embedded in some sort of substrate and has its own motivations and its own goals. All of the goals are still from us, okay? So you can stop freaking out. I promise you that Q star is just a variation of these process reward models. It's a variation of reinforcement learning with human feedback. And that process doesn't even play out in the end product. It is only in the process of training it that this even occurs. So when you deploy the model in its final state, Q star isn't even running. That's just the process by which you update the parameters to get to the model that you want, that does the things that you want. But it's just sampling from the collection of human knowledge. And math is a very structured thing. And all that it needs is already in the model. It's just sorting through the noise. And it's just sounding out the word. It's just showing your work. And that's cool. And that's a leap forward. But it's not AGI. And it is unlikely that they have seen something incredibly terrifying within the company that they're not talking about, that they're not showing. It is more likely that they are just not communicating well, that there are factions within OpenAI and they can't see eye to eye. And they can't integrate those disparate perceptions, and their governance structure is very outdated. So thank you for listening. I hope this all made sense to you, and I hope you have a beautiful day.